Miss Snodgrass, we're doing some fun stuff today. Yeah, we're graphing rational functions.
Oh, that is fun.
Only math teachers.
Today. Remember, you can do this on your pink graph paper. Remember, you've got pink graph paper. You can do the whole problem right on there. Sorry. Oh, yeah. Opt away.
I got it.
Again, show. I should take the attendance.
That's what I need.
No. All here. I know that's a lie. Would you like some pink graph paper? Oh, here's some pink graph paper for you. Bravo. 21, 2, 4, 6, 7, 8, 10, 12, 14, 16, 18. Oh. Give me all the noise. You are all here.
I told you. Why didn't you listen?
I don't know why I didn't listen to you. So, because I thought I heard my garage door opening at 4:18 this morning, so I got up to check it.
Why didn't you go back to sleep?
Hmm?
Why didn't you go back to sleep?
Because it was 4:18 in the morning. Well, might as well do something.
What did you do?
Sat there and started stealing?
Was the garage door open?
No.
He was just being paranoid. I would have been more fun if
You know what it was?
a squirrel.
Washing machine.
Why was it going at 4:18?
Wifey put it on delay.
Oh. We love Lacey.
We do love wifey.
She's so good.
Well,
To me at least.
okay.
Yeah, actually, I have to reach into this.
To do what? That? You look pretty.
Thank you. So I look pretty good.
20.
Yeah, we have the concert chorale singing for premiere today, and then later Pastor Sanders has a gig, and I have a cheer after school, and I have to do Abby Shaw's Santa. Oh my god! So I had to do all this before school, so I didn't take care of her after school. 5 halves is 2.5.
Do it yourself? Yes. Did you make it? You didn't fire the cup yourself? No, I don't like this one. I thought you like, I'm like, you did a good job firing. Like, the handle is good.
She's like, what do you want from me?
Okay, so you know. Where'd you paint it? Oh. Deckanite? Sorry, I missed it. It's alright. I wasn't invited.
It's because it's scary.
What's up?
Keep going.
Show you what I Shoo, Macarena.
Okay, so it doesn't really matter who I got.
No. Okay. Plot points. Evaluation, you don't know which one it's in.
Well, yeah, you do.
Yeah, but sometimes it might be in side by side.
You're joking.
No.
Why would you? No.
Yes.
Did you see our first
Yes.
what? Did you see this?
Say that.
Yes. We did one yesterday.
Yeah. Okay, but it doesn't look like that. I know that because I need to go to
I know, but we might have a side by side.
Right.
Too.
But like, you just have to find one point.
Really, really. What's up? I'm telling you right now, if you're watching along on the internet, you're loving this because you have no clue what's going on.
Lady,
All you're doing is listening.
God, for once I know how to do something. Let me do it.
I don't like any of it. You know what I like of it? I like it. Okay. No offense. Okay. Ready?
No.
Who's yelling at me?
Me, Lizzie. Okay, now I'm ready.
Okay, good, because I'm going. All right. First, what do we do? So what do I do?
You set the denominator.
Set the denominator equals 0. So off on the side here, I'm going to go 2x minus 3 equals 0. 2x equals 3. X equals 3 halves. Agree with that? Yes? Okay, so that tells me that my domain is all real numbers, but x cannot equal 3 halves. Yes? Love it. That tells me that my vertical asymptote is at x equals 3 halves. Yes? Love it. Ha! Degree on the top. 1 degree on the bottom. 1. That means that's same and same, right? That means that we look at lead coefficients, right? Lead coefficient on top, lead coefficient on the bottom. So that gives me y equals 5 halves. Yes? Love it. Step 3, int. So I got to plug in 0. Gives me 0 over negative 3, which is 0. So my y-intercept is 0, 0. Agree. Okay. X-intercept is next. What do I do? So what equals 0? It's the numerator, right? What? But we said yesterday because a over b equals 0, then only a is 0. Right? Because b can't be 0, so we just only have to set the top. We can skip that extra step. Okay? So that gives me x equals 0, so that gives me an x-intercept, I should probably write x-int first, of 0, 0. Agree. Yes? Love it. All right, so now I'm going to pull my graph up a little bit. Okay. And then we go. So, I like an x-intercept, or excuse me, an x vertical axis of 3 halves. That's 1 1/2. That's here. Five halves. That's 2 1/2. That's here. Yes? Okay. See what you did wrong, Danielle?
Yep.
Mm-hmm. x and y intercepts. Okay. T-charts now. So I've got two zones. I've got a left zone and I've got a right zone. So I've already got that in there. So then let's go with positive 1 first, because we can do 1 yet. Okay, so 1 is going to be 5 on the top, and 1 is going to be negative 1 on the bottom, so that's negative 5. 2, 3, 4, and 5 right there. Agree? Okay, and then let's go negative 10. Okay, so that's going to be negative 50 over, what is that, negative 23?
Yeah.
Which is a little bit more than 2, right? Because if it was 25, it would be 2, so it's a little bit more than 2, so let's call it 2.1. What's up?
Do you have to plot that outside point?
What outside
Like
point?
the negative 10?
I like it.
But like, do you need to?
Yeah. Oh, I know. Math makes my brain hurt too. It was so hard. I know. Just on my feet more.
Yeah.
Okay. Then let's go over here. Oh man, I lost my function. There it is. So let's go with 2. If we put 2 in there, then I get 10 over 4 minus 3 is 1. That's 10. Right? Yep. Then let's go 3. If I put 3 in there, I get 15 over 3, which is 5. 1, 2, 3, 4, and 5. And if I put 10 in there, I get 50 over 17, which is a little bit less than 3. Because 51 would be 3. Yes? Oops, this one. That one. Whoopity woppity. Good enough. Good enough. Just need to extend this one down just a little bit. Not that one. Oh, no, tap the brakes. Yes? All right. Now we said we were going to do behaviors. Because we said so. So as x approaches negative infinity, since that's this side, I'll put little like 1s, 2s, 3s, and 4s by it. So that you understand which one is which. This is going to approach, my function is going to approach 5/2 from below. Agree with that? Yep. As x approaches 3/2 from the left, my function approaches negative infinity. This is end is on this side. Asymptote is on right side. Well, I'm just going right across, right? So then as x approaches 3/2 from the right, my function approaches positive infinity. We'll call that number 3, and we'll call that number 3. And then as x approaches positive infinity, my function approaches 5/2 from above. Yes? Got it? Everybody good? Okay. So, again, every single problem, we first find our vertical asymptotes, right? How do we do that? How do we find our vertical asymptotes? Then, we find our horizontal asymptotes. How do we do that? Degrees, right? 3 possibilities. So if top is bigger, then what? None. Bottom is bigger? Oops, not none. Tap the brakes, Linz. Come on, you're better than that. And if we're the same. I had you. Okay. Then what? Then what do we do? How do I find the int? Then I find the x-intercept. Somebody other than Allison. Numerator equals 0. Okay. Then we got step number 5, which we don't have yet because it goes with step 0. We're almost there. And then we got step number 6. And then lastly, we've got step number 7, which is we use the t-chart to find more points. And then that fills us in. Okay? Every single time. No, there's a total of 8.
Okay.
That's step 0.
9. Oh, yeah, I know. Does it go up 9?
It does go up to 7, but it starts at 0. Okay?
Are we